Welcome again to the today's session, the great debate, Industry 4.0 for all. We have a panel of lots of wonderful experts on Industry 4.0, and we're going to have our moderator, Karen Panetta, work with or talk with them. But first, let's set the stage. What is Industry 4.0? Well, let's see a video from an industry practitioner and see if they have something to say about this. Go ahead. I'm not sure if many of you saw the manufacturer there. That was Boston Dynamics. You probably know them as the company that has the dancing robots. But when you think about it, a lot of information shown in that video is going to be part or is already a part of Industry 4.0. So without further ado, I'd like to introduce Dr. Karen Panetta. Karen is a dean at the College of Engineering and Tufts University, and she is going to be serving as our moderator for this panel. Take it away, Karen.
Thank you, President Conrad. It's my pleasure to be with you here today. We have fabulous panelists from every industry and from all different societies. I'm representing today the System Man Cybernetics Society. Also joining us is Rakesh Kumar from the Solid State Circuit Society, Andrea Tonello from the Communication Society, Gordana Velechik from the Consumer Technology Society, and John McDonald from Power and Energy. And we have Lauren Hassan, who is one of our most prominent entrepreneurs, joining us here today from the company Developer. So I'd like to welcome our panelists. And Jim, I saw that robot and immediately all I thought was, well, I could use one of those to clean up my kid's room. But let's talk more about, it's not just about the machinery. We will talk about manufacturing and maybe some of the things that need to happen there. But I want to start off by talking about the human side of what it's going to take to be an Industry 4.0. So I'd like to start with Lauren Hassan, because no one has been more dynamic and done more entrepreneurship than Lauren. So Lauren, can you just comment about, as a human being, the talents it's going to take and what you're going to, what kind of advice you have for people that need to make this shift to 4.0?
Absolutely, Karen. So not only is there going to be a lot of automation, but behind every machine, there's a human, many humans, in fact. And not just important are the technical skills, but the soft skills, the ability to learn and constantly learn. Like the one constant thing that we're going to have in the next revolution here is change, and that we're going to have all kinds of new technologies rapidly coming at us. And if engineers and scientists are not able to adapt to change and constantly learn new skills, they're going to be left behind. And the ones that, there are a number of skill sets that are going to be absolutely critical. Security is going to be absolutely critical. Hardware and software are going to be absolutely critical. And then also data. Data is going to be pervasive they're everywhere. And so everyone has to be able to not only be able to learn new skills and be willing and adaptable to learn these new skills. And those are the traits that every company should be hiring for, not just the hard skills, but the soft skills about being adaptable to change and flexible, but also looking at who is skating to where the puck is going, to quote Wayne Gretzky.
Thank you, Lauren. And that's a great segue, because we talk about specific skills like, oh, you need Python, but we need to think bigger than that. So I'm going to turn it to Rakesh to talk about managing, your career in 4.0. So Rakesh, can you chime in on your thoughts about this?
Yeah, thanks, Karen. And thanks, Lauren, for that introduction. I've been running this roadmaps committee at IEEE, and I've been in the semiconductor industry for a long time. And I gotta say, technology has come a long way. And with 5G technology, there's some examples. Applications have taken off, and then of course the pandemic hit us. So some of the technologies listed here, Internet of Things. You saw some examples in the video. Artificial intelligence, machine learning, virtual reality, augmented reality, robotics, cloud edge computing, software design networks, connectivity, all of these things have come together. And then, of course, came the panic of the pandemic. And I can advance my slide. I'm not able to advance my slide. Michael, can you do that for me? Anyway, what I was going to show you was that digitalization has come around with the pandemic. And if you now do a little search on Industry 4.0 on Google, you will find most companies are committed to digitalization. So what does that really mean? There's a lot of creating digital twins. Let me give you an example. Smart cities. The people have created digital twins, so they're able to adjust volumes and utility planning and all of those things in cyberspace, and then do the implementation. What you saw in the video was smart manufacturing, digital manufacturing. All those things are becoming so pervasive. And data was mentioned. So that's the other committee I run at IEEE, is a database strategy. If you were able to see my chart, what you would see is that there's over 200 zettabyte being 10 to the 21 of bytes of information that is being collected, managed, all of those things. So this is a super exponential growth rate, and I think it's going to continue. So if you were in the industry and looking forward, what kinds of things should you look for? Well, I've felt for a long time that you got to be multidisciplinary. You got to be good at what you do, learn adjacent skills, and be aware of what else is around you. You got to be agile. Don't get hung up on one particular discipline, and then you got to innovate. Kind of Lauren, right? I agree with her. You got to look for where the problems are and offer solutions, and some of those may lead to lots of success. So that's my comments. I'd be glad to answer more questions.
Great, thank you. I'd like to turn it now to John McDonald. John, you've got some great ideas and you have some wonderful experience. Can you share your insight on us with what 4.0 means to you and some of the things coming up? John, you're muted. Can you unmute, John?
I'm still muted. Sorry about that.
Oh, you're there.
Let me go back to the slide here. Now, thanks a lot, Karen. I wanted to piggyback off what Lauren said with people. One thing that we have to do is, and we're doing it at universities, is teaching young people to always think of the big picture. We've transitioned from components, devices, to what we call holistic solutions. And what the customer is looking for is not the separate component, even though it has value. It's the integrated solution. Each of these components has communications capability and becomes a node in a bigger network. And it's the integrated solution that has much more value to the customer. And then both Lauren and Rakesh talked about data. And I want to focus with this slide on how important data is, because for many years we were reactive, right? We waited until something happened. In the electric grid, we waited for a call from a customer that they didn't have electricity, or the utility waited till there was an explosion in the substation and a transformer exploded, and then they reacted. And it's kind of crazy when you think about it. The focus now is not being reactive, but being, moving up this journey. And so the goal of organizations today, not just electric utilities, but organizations, is to be digitized, the journey to digital transformation. And it's moving from reactive through responsive. Today, we're really at predictive. And the focus is on data and analytics. What data do we need? In the electric grid, it's what data do we need so that we can analyze the health of a particular asset and predict as many of the failure modes of that asset as we can. And, the idea is with analytics, the right analytics and the right data, prevent a problem from happening, right? Prevent it from happening, address it from the very beginning. But what's exciting today with this journey is we're really just halfway up the curve here. And I think that's what's exciting. Next is prescriptive and eventually autonomous, where we're self-healing, self-provisioning, and extensive autonomous operations with limited human intervention. This will require more artificial intelligence, more machine learning, and more use of the digital twin, which is ongoing today. Whoops. Let me go back to whoops. The other thing here would be we've heard of the Internet of Things, and really this gives us the focus on data and analytics that I was talking about. This next productivity revolution is really connecting, which is with communications, intelligent machines, big data and analytics, and really connecting with people, no matter where the people are, anyway, any place, anytime, for intelligent operations. And where all of us are looking at this productivity revolution, says, how can we leverage this for our own companies and the work that we're doing, to get the most benefits? All right. So those are a couple points I wanted to go over, Karen. I'll turn it back to you.
Bit of things. The theme right now I see is a lot of people, being predicting rather than reacting. As someone who co-invented the first digital twin, I'm happy to hear everybody promoting digital twins. But I want to talk about some of the, we talk about diversity now is on everybody's mind, and inclusiveness. And one of the most predominant fields right now that are attracting underrepresented groups is something that has huge social impact. So I heard John talk about giving the big picture, which is really important. So one of the fields that really is attracting more people because it has huge social impact is healthcare. And so I'm going to turn it over to Gordana right now to talk a little bit about her perspectives.
Thank you, Karen. Well, we all know that healthcare is actually multidisciplinary. We have lots of disciplines that bring a big picture to healthcare. But in Industry 4.0, we have also a multi-technology approach, and we have intersection with, for example, quantum computing that is emerging in big steps now. Artificial intelligence, Internet of Things, robotics, AR, VR, cybersecurity, cloud computing, big data, blockchain, and so on and so on. Lots of buzzwords that are connected to Industry 4.0. And as in Industry 4.0, at the beginning, one of the buzzwords was basically factories. Here we will have smart hospitals and healthcare extended to homes and social environments. So with robotics and mobile surgery operating rooms and stuff, I will not be surprised that we will soon have surgeries at home. So in the past, we would visit doctors when the problem is visible, and then the doctors would capture the aftermath of the problem. But now, with continuous monitoring, we are more and more into the predicting phase, and then we want to prevent any health care event, any health event that can endanger our health before it actually happens. And we are able to record the event and analyze before and after things when that event, for example, a heart attack happened. So we can see the time development and we can react accordingly. What is also happening in healthcare industry is redefining, the thinking is redefining. We are also looking at some new expertise that this Industry 4.0 is going to bring. And of course, personalization of the healthcare. So lots of things that are developing today target a person per se instead of demographic picture. Of course, this also brings into the stage things like regenerative medicine and higher complexity of therapies. And we will see that more and more, but we will also see some of those really high complex therapies applied at home, for example. And as with everything, challenges that are in healthcare with Industry 4.0 can be challenges that are already inherited from co-disciplines. Maybe we need a better sensors, a little bit better approach in some models, but also something that is intrinsic to scientific tools and methods. For example, we all know that artificial intelligence, a huge problem was a bias or noisy data or something like that. So those also reflect in healthcare. And another thing is we need to turn curated data into knowledge. What does it mean is we can look at something and look at it as a black box. We see that if we put something, we change something, and then we look at the outside. So we see what happens, but we don't know why it happens. For example, in regenerative medicine, we still don't know why lizards can regenerate some parts and humans cannot. So I'm hoping to see with this huge leap in every technology that we are looking today, and the pace of changes is really great, answers to questions like this one. So that's a few outlines just to spice up the debate.
So I'd like to turn now to Andrea. Andrea, you're representing the Communication Society. What do you see as some of the biggest challenge coming up? What are your comments on all of this?
Yes, thanks, Karen. Yes, indeed, I represent the Communication Society, so I do my, let's say, research and development activity in the domain of telecommunication networks. And as it has been already anticipated, telecom networks play a key role in Industry 4.0. If we need an infrastructure, let's say in hardware and software infrastructure that is able to collect data. So we need sensors, we need telecom technology to acquire data and distribute data to the right place. And we also need control and therefore intelligence, as it was already said. So I would say that the telecommunication network is the backbone, is the the part that connects the other parts. What I would also stress is the fact that the intelligence part. It has been already mentioned that digital twins are important to have a digital model of all process and procedures in the Industry 4.0, so that we can essentially understand what's going on. We can try to optimize the procedures and control better the procedures. But also, again, Industry 4.0 is also about, again, I stress this, infrastructure. So we need, we need the devices. And not only for automatization, I would say, which was maybe the first wave of robotics, just to replace, if you think to anthropomorphic robots that helped, humans to carry out heavy tasks. Now is to include robots connected to telecommunication infrastructure that are capable to act intelligently. So we need indeed intelligence. So guys like me that work in telecom network, work in topics like efficient data transfer, reliable data transfer, low latency data transfer. So these are also I would say, the challenges in R&D in the domain of telecom networks, and also the work in computing, because now we can, as I said, cannot forget about processing data. It's not only transferring data. So this is why telecom guys work in looking at paradigms related to edge and cloud computing. So essentially to understand where to put the processing power, the intelligence power, which helps also, let's say, designing and customizing better the telecom network, so that we connect basically the right points of our overall infrastructure.
Okay,
This is what I would say.
Thank you, Andrea. So, so far everybody's agreeing. So we have to have a debate. So I have to throw out some difficult questions here. And the first one is, I'm going to look at this and say, let's talk about, Industry 4.0 in manufacturing. We saw the robots. We love robots. They're getting better, helping, assisting humans. They're not going to take over the universe. We can debate that question. But I want to talk about supply chain management. So, we saw during the pandemic, you couldn't find toilet paper or something couldn't happen. Why is this all going to be fixed now? Why is Industry 4.0 going to fix that? Or are we just wishing? So I'm going to throw that out there to anybody who wants to answer it. What do you think about supply chain management? Is it really going to improve, and how is it going to improve?
I can make a quick comment on it. Yes, break ice here. I think it's connected to what we said. Supply chain management will benefit greatly because of this ability of creating digital twins. So to have really a model, stress all parts of the supply chain and see how they basically react, so we can run optimization. And as it was said before, we can play not react in a reaction mode, but in a predictive mode. We can infer what basically the needs are, or what can happen in all the processes involved in the production of services for goods.
Okay, and I like that because when I did digital twins, I was doing like all semiconductors, and I knew all the different types of things. But here we're talking about populations and people and disparate data sets. So if we think about the data, right, getting that data is going to be a challenge. So I would say, well, if we could have digital twins, that would be great to model the process of well, is there a drought? Is there has there been rain, a fire? Has there been some other types of pandemic going on? That you look at all these if then else types of conditions and you try to predict for those. So, but try to get data. Like one of the things that we talked about in the healthcare is a lot of the data that's collected on human beings right now is old. So we in trying to annotate that. So while there's tons of data out there, trying to annotate it and use it right now and get a ground truths is the challenge. And you heard about bias. So, so while it sounds nice, think about the data. I've heard several of you talk about the data. Does anybody else want to chime in on how important that is? Go ahead, Joel, please.
So data is really important, but the data is only good as who is interpreting it and who is writing the code that's interpreting it. And Melinda Gates is a fantastic champion of this, of getting more equity in people who are interpreting the data. And we've seen numerous high profile examples where there's something as simple as screening candidates for job applications where there's bias introduced into the data modeling for that. And so that's why it's so important that we get equity, that we have equal representation or representative representation of all individuals, gender identities, ethnic backgrounds, racial identities at the table, so that we can do our best to eliminate that bias and make sure that we are correctly interpreting the data, not just interpreting it with bias.
And it comes back to people again, right? It comes back to, so it's not just all about the technology, it's really about the people, which means we're probably going to have to look at education and leadership differently. So, you know, one of the challenges that we talked about on this panel, or when we were prepping for this panel, was the lack of unified leadership that makes integration and cross-unit coordination difficult. So what kind of leaders are we going to have to make to make Industry 4.0 work, John?
I think one of the biggest problems is not technology, but it's people, it's culture, and it's the resistance to change. I think one of the biggest roadblocks to any industrial revolution progress is the people part. And that's why I tell students, in addition to engineering courses, you should take some psychology courses, because developing the technology easy part, convincing a customer to adopt your new technology where they'll have to do something different in the future, is a challenge. And our organizations are too siloed. Mm-hmm. You know, every group has their own data, their own applications, and there's no sharing among groups. So the leader, really, truthfully, the leadership needs to, and the reason is that the groups are incentivized to do well, but the organization doesn't incentivize groups to break the silos down and do things holistically, mm-hmm. company-wide. Okay. Mm-hmm. Our incentive structure that's put into place by leaders does not incentivize the right things. Okay. And so I think from a leadership point of view, we have to look holistically, which we don't do today, mm-hmm. and break down these silos and convince groups to work with each other. There should be a sharing of data, not a hoarding of data, you know, and that's one of the big problems we have in the industry. And I find an organization has trouble breaking down the silos themselves, because if any person tries to do it, they're viewed having political baggage. You know, they're gonna favor their own group and not favor others. Mm-hmm. I find it almost has to be somebody, when I was doing consulting work, somebody coming in as an independent consultant who had the experience and knowledge, but no political baggage in that organization. And then everyone would do what I recommended they do. Mm-hmm. But for an organization to do it themselves is very difficult.
Right. And even that, John, you make a really great point, because even in academia, you know, playing it safe and keeping your head down is like the mode of operation. And the ones that are the rebels that really want, even though we say we want change and critical thinking, they're the ones that, you know, they're warriors for us, and we appreciate them, but they get their heads chopped off. So we do have to change the mindset. Rakesh, you know, you've got some great insight on this. Oh, you're muted. You're muted, Rakesh.
You're muted.
By Rakesh on mute, maybe I can jump in with. Well, it turns that we need to be adaptive and flexible, and we also need to be prompt to recognize if there is a new skill emerging that we didn't have before in, for example, curriculums. And also we need to see how we can easily transition to those new skills, like create a talent pool for those new skills. That will also accelerate adoption of the things, and maybe prevent that we don't have a toilet paper in the future, although we have all the technology and all the algorithms that can prevent that. Mm-hmm. So something in that line, perhaps we can go.
Perfect.
So, Rakesh, are you unmuted?
Yeah,
Yes, you're
I'm
muted now.
unmuted. Yeah.
Oh,
Hey, thanks for bailing me out there. No, I think all good points are being made. I'd like to go back to Karen's point about data. You know, where is the data? I think there's a lot of organizations that generate data, but there are mechanisms for storing and sharing that information so others can use it. I think there's a huge opportunity there. So if you're a data scientist, you know, figure out ways to do that better. I mean, even within IEEE, we've got so much data, we don't know what to do with it in a sense, or how to do with it. And you know, part of this committee that I'm running, we're looking for thoughts and ideas. It ends up being sort of a cultural change that you have to make. You know, it's been said that oil is the new data, but what we're finding is, you know, oil can only be used once, right? Data can be used multiple times. So once you have the data, you got to be able to store it, share it, others can use it, and I think that's where the future is going.
and you know, one of the things I'd like to jump in on there is we're talking about data, but yeah, let's talk about the difficulties integrating data from various sources and those IoT devices and security. So we haven't solved that. Are we even, you know, how important is that in the future? And are we really going to work on that stronger? So Andrea, what do you think?
Yes, I think well, I would like to elaborate a bit more to what also John said before, related to the challenge of adopting Industry 4.0 paradigms and technologies. A lot is about fearing, you know, new technologies, and the only solution, in my opinion, is really raising awareness and educate basically people in all aspects, starting from technology aspects. And in this respect, universities, since I'm, you know, this is my role is being to be a professor, I think I have these responsibilities, you know, to render these new technologies more user friendly, more understandable, so that you know, adoption of them will not create you know, this great fear. I also, if you think about robotics, there's been a lot of discussion about, you know, using robots that will replace human activities, so we don't need humans anymore, or artificial intelligence. So the world will be dominated by machines, and humans basically won't be able to control them. I have a totally different opinion, and I believe that all of this will create really more opportunities to humans, you know, also to shift a little bit their center of activity, let's say, and moving a little bit more, maybe, you know, removing heavy tasks and moving more into creative activities and jobs. So this is if I have to go back a little bit to discussion of what the challenges are, what,
Right.
in my opinion, is very very relevant. Of course, you need also to explain what the industry gains out of this. You know, why you can create your business, why your business becomes more profitable, why you have a more, I don't know, human-friendly environment or job environment, or actually you are more environmental friendly in your process and procedures. So again,
Yeah,
you need to explain this.
I think you're absolutely right. I think that all over the years, as automation has stepped in, you know, step by step, everybody said, "Oh, we're going to lose our jobs and stuff." But you know what's happening is, if you draw yourself a vertical supply chain, things are moving up the rank. So the more menial tasks, if you will be done by robotics and automation, but the higher level thinking process, the interdisciplinary things, all of those things are going to be human, right?
My,
Go ahead. Go ahead.
yeah, I agree with all of you, but there is something that coming from Consumer Technology Society, we see that things really go rapidly and they get accepted really rapidly when you put it on the level of consumer. Look at the mobile phones, how rapidly they developed, but not before they became like fully consumer friendly. So maybe if we can think of something that data is also new oil for consumers, so that consumers could use that data for some their applications or something, probably it will be shared more and used more and extracted more information from them. So lots of things can happen if we can put data at the consumer level.
But I think, Karen, I think what Andrea said is very important. We develop new technology all the time, and we that develop it, we always assume that the people that we want to convince to use it know as much as we do, and we don't. And Andrea's right. We don't, and we wonder why hasn't this been adopted, and we have to step back. People will only adopt. They will only use what they understand and what they feel comfortable with. Okay. And we don't spend enough time. We don't spend enough time, as much time as it takes to really make people feel comfortable and understand what this new stuff is. And I think with the Industrial Revolution, if you don't do that, spend time with people or companies or groups and really go through what it is. You're gonna have resistance to change. You're gonna have a slowness in adoption, or maybe a lack of adoption. And I really think that's important. We really have to take that into account. Technical people always assume wrongly that the people you're talking with have the same level of knowledge as you do. And you really have to step back and say, how much, what do I need to do to make this person understand and feel comfortable, or this group, with what I'm trying to discuss?
So, John, let me disagree with you a little bit. I agree with you to an extent, but the average individual does not have to understand the technology. What they understand is their problem and the application. I think it is up to us, the developers, to make sure that we're solving a problem that they are having. I think to Gordana's point, people in India and worldwide are using the smartphone for video, right? They're using that data information because they like to watch videos. Smartphones cannot do it. They don't understand how to do it, right? That's what I'm disagreeing with you, John. But I think you got to work on the application side of things. Make sure you solve that problem.
And I just want to point out that IEEE has our Humanitarian Activities Committee. And that's the first rule. I think you both are actually agreeing because you have to understand who you're serving. And you have to make sure that whatever you design is conducive to them. So whether it's a culture, whether it's resource constraints, rather than saying, I have a technology here, it's going to solve your problem. It's that two-way communication to understand what is that problem. So I think that that's a big one. But this makes me think a lot about apps and standards. So Lauren, you write some huge, some very predominant famous apps and in streaming and things like that. You're really groundbreaking pioneer in some of these things. Can you talk about the standards of, some third party comes up with an app and, I'm going to use it in a third world country and there's no support for it. There's no standards. What do we need to do to fix all this?
Yeah, so the public consensus is the ultimate voting machine. We saw it with the Blu-ray DVD versus HD DVDs back 20 years ago. And the public is relentless in letting you know exactly what they want. And I think standards are really important, and that's where guiding institutions like IEEE and government institutions have a role, and this is a multivariate challenge that we're solving. And so, yes, we need to have these standards in place, but we also need to take into consideration where is the public land on the different technologies, and how can we look at adopting things globally. There's still third world countries that are using dial-up and flip phone technology without a smart screen. And so part of that is accessibility and thinking about your whole user base, not just your first world country user base.
Okay, terrific. Thank you. And I see we have a question, well, it's in the comments. And we post that question so that everybody can see it. There you go. So the question to the panel is, what advice would you offer to the audience to help affect the needed culture, societal changes to help the Industrial Revolution advance? Well, I think Lauren just gave us some, and I think John McDonald's gave us some, but who would like to chime in on this one?
can I piggyback on what Lauren just said about standards?
Sure, absolutely.
I think, you know, we need standards, but we don't want each country to have their own standards, you know, because we want global standards. And the reason is, you know, with the revolution and with products and industry, if each country had their own standards, we develop something in one country, we take it to another country to try to sell it, and they don't understand how it operates because they have their own standards that are different, you know. So if we develop, you know, what we've done in the IEEE in the Power and Energy Society is work on harmonizing standards globally, you know, because that if you don't, it's a barrier to trade. And you have each, without standards or global standards, you have each company and each country doing their own thing,
Mhm.
and nobody's coordinated. So I think standards are critical, and as much as possible harmonizing standards, you know, so each group or each country doesn't have their own, but we have a set of global standards.
And,
Can I?
yeah, I was gonna go to you. Go down to next. Go ahead.
Okay. I just wanted that question that was like, what advice? I think I would say be creative and don't be afraid. Just be courageous and see, because there is a lot of opportunities to create something really new. We need lots of new skills. We are witnessing how the landscape is changing rapidly. And so there is a lot of opportunity for everyone. So just go ahead and put your creativity and just see how you can contribute to this. Or if you can come up with something new, or you know what the challenges are, or things that you're frustrated with, and just think of the solutions, and then go and be part of panels like this and suggest solutions, for example, or ask some of the experts, like, look, I have this solution and I see the problem here and here. Because sometimes we are not aware of the problem, as John said, and everyone else here pointed out. Sometimes we are too much engineers. We just think that people should understand how things work. So just show us wrong and show us how you see the things.
Yes, I would, if I may,
Please.
I would add, yes, exactly what we said also before. Try to educate people, and to add something more, what I said before, is create opportunities so that people or different entities can talk, can understand each other, explain what the requirements or desires are, and how technology can support fulfilling those requirements, and so on and so forth. Yeah, we have to understand we are talking about, in many cases, not in all cases, of industry for industry, in the sense that new industry will be created to generate solutions that can help other industry, other companies, let's say, in more traditional sectors. So we can also give an example, also to speak a little bit more concretely. If we think to the agriculture sector, which is traditionally considered conservative and not high tech, but now we are talking about adding IT infrastructures to help agriculture. Now, how can these two communities speak the same language? We don't need to go into the technicalities of technology, but we need to explain what technology can do, which is also what Rakesh basically said before. And we have to create opportunities so that they can sit together. Maybe also creating models and, let's say, protocols just for this communication.
Yeah, exactly. I think I had attended a talk by John Deere executive a few months back, and it was extremely impressive how they're doing precision agriculture, and creating the connectivity and the solutions out there, and just lots of opportunities. The other comment I would make is, here's an opportunity in standards. Everybody's kind of creating their own digital twin models and digital twins and using them. Shipbuilding industry is creating their own digital twins, for motor and stuff. There's all kinds of standardization opportunities that standards bodies need to step up and make it easy for the next person to design those models and the digital twins rather than start from scratch.
Absolutely.
Go globally, like John said, right? So.
And we do have a question in the chat, if somebody can post that. Oops, it went away. There we go. So it's saying, could each of you give an example of one action that you or your company or colleague has taken to prepare for Industry 4.0? So how about we start with John? I'll start with you.
Yeah, I'll tell you the biggest change for us and for our industry is for the first time hiring data scientists. We had never done that before, you know, and what's unique is we're hiring data scientists who have no domain knowledge at all of the power system. Not at all. They're data scientists. Well, what we found was, and this is unique because we're a very conservative, and you know the power industry is very conservative. I always say what's on the Missouri license plate is our industry. It's called the show me state. You can show me 100 times that other people are doing it, and I'm still going to think about it. You know, it's very conservative. But we're hiring data scientists, and what's really cool about this is, as you teach a data scientist a little bit about the grid, they have fresh new perspectives about what we can do to improve the grid. And what I mean, new perspectives from a data science point of view, that those of us with years and years on the electric grid have never thought about before, you know? And so that's what's exciting about it. What we're doing is something new, hiring data scientists, teaching them about the grid, and then incorporating their ideas. And like Gordana said, you know, be creative. You know, these are fresh ideas that we never had before. And so not just vendors, but utilities, you know, all organizations are employing data science in a much bigger way than we ever did before.
Thank you. Someone else? I want to talk about it?
This is Rakesh. I would do two, actually. One for IEEE. I think we're bringing IEEE into the Industry 4.0 revolution, if you will, by looking at this data committee that I was talking about, what to do with our data. And on the semiconductor industry side, you know, we've actually been in Industry 2.0 robotic manufacturing for many years, and are continuing to advance that. So I think those are both exciting areas.
So I'll answer this on both the personal level and then the company level. Personally, as an engineer who's still practicing, I've adopted new skills. I got security skills, and it was hard to start over. It was not easy. There were tears that were shed, if I'm being honest, but it was absolutely critical to my success and ability to continue to innovate and get those skills. And then what I've done with developer, and Karen, you know this firsthand, is I've made an international platform that makes it the norm and shows the playbook of how to move forward and retool and constantly learn and then become an expert in your field in a constantly evolving industry. And I work with not only universities, but companies and individuals alike for women and underrepresented individuals to get that equity at that table. And I think that it's important that we make an investment on that front.
Terrific. Thank you.
Gordana?
Yeah, I can answer. I agree with Lauren. Maybe sometimes we are not even aware that we are acquiring new skills because sometimes it goes really smooth because we need to solve a problem and then we research and all of a sudden we have a new skill. And but in the enterprise that I work for, what we did, for example, is rehabilitation robots. We connected them with internet and we followed up at home the rehabilitation. So it was one of the things like a step forward. Or in regenerative medicine, we also are adopting new tools like artificial intelligence. And recently we are looking at quantum computing because it's a little bit exotic and kind of promises a lot of potential. So, you know, kind of wakes a lot of curiosity. Can we adopt this or not? So it's a challenge.
Thank you. And Andrea?
Yes, in my case, I mean, if I bring the point of view of university, you know, one of the activities that a research group at university is one of the important activities is creating project proposals. And typically, in the past, we used to create project proposals in specifically your scientific field. If you work in telecommunication and communication theory, you used to propose projects and just in that field. Now we are a little bit looking more at the applications, I would say, of telecommunication technology, and therefore we have created opportunities to share ideas with companies and industry that are actually not in this domain, but they have interesting applications that can benefit from the deployment of telecommunication technologies and also signal processing, data analytics, and so on and so forth. So this is what I think is a little bit the novelty. An example also, again, if I not to talk about agriculture, but the wood industry, there have been a lot of interaction with companies in that domain to explain, to basically share ideas and try to conceive, ideas on how to explore and exploit IT for the wood industry, or maybe to monitor forests and the wood assets and so on and so forth. So this is, again, an example of contamination going across, I would say, the field.
Yes.
And it's also a concrete action, I would say.
Yes, we're all related, everything's related, our environment, where we live, the people, the animals, everything. So this has been a lively discussion. I want to thank each and every one of our panelists for joining us here today. And if any of our HKN viewers have questions